Okay, so a few times I've designed this damn thing and gotten it working, and obviously forgot some shit along the way, you know. But here we are, and this thing is decent. Upping the order of the learning rate by a power of 10 essentially has allowed this to start picking up much quicker, but it still hasn't fired yet because it can't reach quite the correct precision in order to do so. Of course, my kill radius is only 2 meters, and that's kind of low for a cannon. It's about 15 meters for shrapnel. So, yeah, yes. I remember talking with Zimmerman about doing this as a random forest, and I look at the random forest the way I looked at it last time, and I was like, that just doesn't make a whole lot of goddamn sense. I mean, I could approximate by, but basically what he described was an overfitting problem, essentially. You know, where basically this thing ends up getting fit for everything. Well, as you can see, it's already learning very quick now. You know, the question is if I go over the same data, what will happen? You know what I mean? That's really what I should do, is I should create a fucking, like, because I have this thing responding to very specific things in a very specific way. If something's out of range, for example, and it's not returning out of range, it fucking stops on that and trains it until it hits out of range. It doesn't care about the other parameters really, just out of range is, you know, above 0.75. I've increased the, I figured that just saying 0.5 is nothing and anything greater than 0.5 is something didn't make a lot of fucking sense. So for a Boolean, so I just divided the range to 0.5 to 0. Less than 0.75 and 0.75 up, essentially, to indicate a positive response, which has improved performance considerably. As you can see, it's still searching hard at points, but that's because it's adjusting the actual speed. That's the cool thing. I built in a maximum speed, and it adds it takes that times and it creates a coefficient for it, basically. So it knows how fast to move. That's why it's doing what it's doing right now, which is bouncing back and forth. The only issue is essentially I might have to just actually start over each frame, you know, at the actual location it originally started over to finish it up, which might be an additional freaking step, because it's going to be kind of jumpy here at various points. So the idea is that if it's bouncing itself around, it's going to eventually find the thing it's supposed to find, and that makes some sense. But I'm kind of proud of this. This is my very first project, even if it's a repeated one, you know, that I am intent on getting to work. It's going to work. Theoretically, it makes sense that it should be able to work. The only thing you could really fuck around a bit is, you know, training multiple muzzle velocities and multiple freaking like H max and V max like velocities as well, or maximums, you know. I mean, I set an overall max for normalizing them, but I actually select in the parameters. I actually select a horizontal rotational velocity and a vertical rotational velocity, and also essentially a muzzle velocity as well, based off of what I consider to be the maximum in this code, which is like the maximum cannon or artillery shell that's possible is something like 340 freaking meters per second. So, you know, that gets factored into this as well. You know, and then the normal things like the turret freaking position and that, like. So there are certain things that are stable in this training run that one might wonder why I even fucking include. I include normalized values, so, you know, fuck it, man. I imagine I'd end up training this per freaking, like, you know, difference or major difference in, you know, the ability to perform of certain things. So yeah, that makes sense. As you can see, I mean, honing in pretty freaking quick, but I honestly think that I should be keeping track of all the data that's already been trained into it and then start from the same point and see what it does, you know? As you can see, I mean, this would take a very long time to actually finish. And this is not even what I would refer to as overfitting for the most part, because it's had to fucking, like, correct itself multiple goddamn times, essentially, and it hops to different positions consistently every time it fucks up. So, yeah, man, it's, cool. And I only let it train for the same target for 500 batches. And they're batches of 100, so, you know, you can see this is going pretty goddamn fast, too. So, I mean, we will see. Also, 50% of the, 50% or a full 50, there's a 50% probability that it will, every single time it's running, it's about to update a frame, that it will start from the center frame and have to work out from that, which is sometimes what you see where it suddenly resets itself to the center. That's intentional, you know. So it has to take the steps essentially at the proper velocities from the starting point to the target again. So yeah, I think this is pretty cool. I don't know if it's going to work at this particular point. Like I said, this is my first project. It could be a failure, you know. According to Zimmerman, it would be a failure. Blah, 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 blah. And it's like, yeah, well, I didn't have to learn it right yet, so I mean, I guess I did. I just guess I didn't have time enough to really run it. But, yeah, it will be interesting to see. Now, here's the thing. It doesn't ever see data except for data that's randomly generated. So, like, I randomly generate a target, and then within the range, and out of range as well, and then I go ahead and I calculate what the desired outputs are, and I train from there. So it's not going off a static set; it's going off a continually changing one. So that's something. It's interesting. And we'll see whether or not it works.